Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 87. So we have a circuit here, and it says it's a primitive 4-bit digital to analog converter, or DAC. In this circuit, to represent each digit, 2 to the n, of a binary number, a 1 as the nth switch closed, whereas 0 as the switch open. Okay, so for example, 0010 is represented by n equals 1 closed, while all other switches are open. Okay, and for example, 1000 would be n equals, sorry, I just realized I wrote this wrong. So 0100 is n equals 1 closed, and the rest open. 1000 would be n equals 0 closed, the rest open. 1111 would be all closed, for example. Okay. So show that the voltage V across the 1 ohm resistor, so we want to measure across the 1 ohm resistor, for the binary numbers 0001, 0010, 0100, or 1000. Sorry, this last one was wrong. 1010. So these represent 1, 2, 4, and 10. Okay, so we want to see if these follow the pattern we should expect. So I'm going to go ahead and call this case 1, case 2, case 3, and case 4. Okay, so let's do case 1. Sorry, this is 0. This value is the 1 switch, 2, and this is switch 3. So these are the digit values that correspond to the switches. So if we're going to do case 1, this is all open but n equals 0 closed. So this is case 1. Okay, so the effective resistance in this circuit is just 16 kilo ohms, which is just the one resistor it goes through, which means the current is given as 16 volts over 16 kilo ohms, and this comes out to being 1.0 milliamps, which means the voltage across the 1 ohm resistor, V, is given by IR, or just 1 millivolt. Okay, so there's case 1. Let's go to case 2. Case 2 says n equals 1 closed. That's this case. Again, we're only going through one resistor, so the I is given by 16 volts over 8 kilo ohms, which is 2 milliamps. And again, measuring in the 1 ohm resistor gives a V1 of 2 millivolts. Okay, move on and do case 3. So this is n equals 2 closed, or this case, where you calculate everything analogously. 16 volts over 4 kilo ohms now gives us a 4 milliamp current, or a 4 millivolt voltage. Awesome. And now lastly, I wanted to switch back to black here. Let's do the last case, case 4, which is n equals 3, n equals 1 closed. So that's this one and this one closed. So this one's a little bit trickier because now we have 2 resistors we need to think about. But all we need to do is find the equivalent resistance, which is 1 over 8 kilo ohms plus 1 over 2 kilo ohms, all inverted, which is 1.6 kilo ohms. And now we know that I is 16 volts over 1.6 kilo ohms. This comes out to being 10 milliamps. amps. If we measure 10 milliamps in a 1 ohm resistor, we get a voltage of 10 millivolts. Okay, so now just as a overall checking here, in case 1, we want to represent the value 1, we get 1 millivolts. Case 2, we want to represent the value 2, we get 2 millivolts. Case 3, we want to represent the value 4, we get 4 millivolts. And lastly, case 4, we want to represent the value 10, we get 10 millivolts. So everything works out, just checks out exactly as we would expect for this problem.